So let us now learn the force that is in space. A force that is inclined to x, y and z axis. So now we can find out, or we can get the rectangular components for this force. So when we resolve this force into horizontal component and vertical component, the vertical component becomes Fy and the horizontal component is inclined to x and z axis. So Fx can be obtained by resolving into horizontal and vertical component. So the horizontal component is this and the vertical component is this. Now if we square this f square, f is OA, so OA square equal to OB square plus BA square, so Fy square plus F height square. F height square is OC square. OC square is OD square plus DC square. Okay, so now OD square is Fx square, CD square or DC square is Fz square. So now this F square can be substituted here. So we get F equal to under root Fx square plus Fy square plus Fz square. So we get the magnitude of force by just squaring the components and summing it up under the square root. We can also look at this force, or we can also resolve this force into directly using the angle. So theta x is the angle of this force to x-axis. So this is Fy and this is Fz. So if we resolve Fx equal to F cos theta x, F cos theta y is Fx Fy, and F cos theta z is my Fz component. Generally when we write the force vector is Fx I vector plus Fyj vector plus Fzk vector. You substitute this for Fx and Fy, Fz, we get this, and this is nothing but the unit vector. So that is the lambda vector. The magnitude of it is 1. It can be also written as the squares of the cos thetas, and then cos theta x goes, how to find out cos theta x? Fx by F, cos theta y, Fy by F, cos theta z, Fz by Z. Now a force defined by its magnitude and 2 points on its line of action. The force in the line of action of the force, know the starting point and the ending point. So if we find out the direction, the lambda vector into the magnitude gives you the force vector. So the force vector is the magnitude into a lambda vector. So lambda vector is nothing but the distance vector by the distance. How to find out the distance vector? Mn, okay, that is the x distance I vector plus y distance. So this is x vector, I mean dx, and this is dy, and this is dz. Okay, how we get Mn? It is nothing but the distance. Distance is under root dx square plus dy square plus dz square. Then you substitute lambda vector here to find out to get F vector. So addition of concurrent forces in space. In a point we may have 3-4 forces acting. So then summation of all the forces will give you the resultant, and resultant will have x, y, z components. Similarly, each force will have x, y, z component. So Rx is summation of Fx, Ry summation of Fy, Rz summation of Fz. So the magnitude of the resultant Rx square plus Ry square plus Rz square under square root. And the theta inclination of the resultant force can be obtained using the corresponding cos theta, okay, formulas. So Rx by R, Ry by R, and Rz by R. Now let us solve this problem. Okay, in this problem we have to find out the resultant of P vector and Q vector which are in space. Okay, so replacing these two vectors with a single vector called the resultant vector, and it will have the inclinations. Now let us solve this problem. Okay, so there are two forces P and Q. See, please understand, on seeing the three-dimension information on a two-dimension paper or the question paper or the book or the board, okay, where this force is acting and where this force is acting. The red lines are the forces, okay. So we need to find out the magnitude of the resultant and direction of the resultant. So magnitude R vector, the resultant vector, is summation of P vector plus Q vector. Okay, the components can be written as Px I vector plus Py j vector plus Pz k vector plus Qx I vector plus Qy j vector plus Qz k vector. So summation Px plus Qx I vector plus Py plus Qy j vector plus Pz plus Qz k vector. So this is going to be your Rx, Ry, or Z. Okay. So the magnitude can be obtained by Rx square plus Ry square plus Z square. We can find out the magnitude. The inclination, how will you find out? Theta x, which is cos inverse Rx by R, theta y equal to cos inverse Ry by R, theta z equal to cos inverse Z by R. So if we understand this, now we have to find out Px, Py, Pz for P and Qx, Qy and Qz for the force Q. Now how to resolve this? Okay. So if you take this as the plane for Q, I'll just deal with Q now. Okay. So if I bring to a horizontal, okay, so it is like this. You assume the board, okay, it is behind. So if this is Z, this is X, okay, and this is Y, this force is like this.
So the horizontal component, the vertical component. If I resolve this horizontal, okay, then this is further inclined to x-axis and z-axis, okay, and the vertical component is directly fy. That is what we already discussed. Okay, so I'm going to get q horizontal is 400 cos this angle 50 degree. Q vertical is nothing but qy equal to 400 sin 50. Okay, so now since it has this horizontal force is inclined 20 degree inclined to x-axis, I am going to find that. So qx is q horizontal cos 20 degree. Q is equal to, okay, q horizontal sin 20 degree. Okay, you calculate this and you can substitute. I will just write the values. So 400 cos 50, 257.1. Okay, so qx, so the qy is 306.42 Newton. Now q horizontal, you substitute that 7.1 cos 20. So this happens to be 241.6 Newton. This is, see, when you are representing this, it is, you are taking the z, it is coming down, this component QH, okay, will close theta, that is QX, and when it is opening, it will come here, okay, that is negative. So this negative you have to put. So negative 257.1 sin 20 equal to 87.93. Okay, right. Now similarly we can do for this P. Okay, P will have horizontal component. P horizontal is 300 cos 30. Okay, and P vertical is nothing but Py 300 sin 30. Okay, and then Px, the horizontal component, if it is closing, that is Pz. So I will first find out Pz. Pz is P horizontal, okay, cos 15 degree. Px is in the negative side, so negative Ph sin 15 degree. So Ph horizontal is 259.8 Newton. Py is 150 Newton. Okay, Pz, so 259.8 cos 15 equal to 250.95 Newton, and this is negative 259.8 sin 15 is minus 67.24 Newton. Okay, now we have found out all the components. You can find out Px plus Qx, you can substitute every component there, and px, qx, you'll get, okay, minus 67.24, minus 67.24, qx is 241.6. Again, you can substitute all and then you can find out Rx, Ry, Rz. So that happens to be 174.36 and 456.42, 456.42 and 163.02. You substitute all this, R value will be equal to 515.1 Newton. You are substituting all this and then you get resultant as 515.1. When you are substituting for theta x, the inclination, so the magnitude is 515.1 for these two forces, and the direction is theta x, theta y, theta z. And you are substituting 174.36 by 515.1, you get 70.2 degree, 27.6 degree, and then 71.5 degree. Okay, now substituting Rx by R, Ry by R, or Z by R, you are getting this degree. So that one single force replacing P and Q is 515.1, and with the inclination, or the inclination with x-axis, inclination with y-axis, and inclination with z-axis. I hope you have understood how to find out resultant for a system of force that is acting on a particle in space. Now, let us discuss equilibrium of a particle in a space. So, the forces are in space. Okay, so 3 dimension. Say for example, this is a particle A and it is having some weight W, and it is tied by 3 ropes. So this is one, this is another, and one more is here. All the forces are in space. So you take coordinate system. So this will have a coordinate point x1, y1, z1. This will have points x, y and z. This will have point and coordinate points, and this will also have the coordinate points x, y and z. Say for example, this is B, this is C and this is D. Okay. So now how to find the equilibrium? As we have already discussed in 2-dimensional case, the resultant should go to 0. Okay. The resultant vector should go to 0. So now how many forces are there? There are 4 forces. Okay. So this will have a tension, this will have a tension, this will have a tension. So the magnitude of this is TAB, the magnitude is TAC, and this magnitude is TAD. Right? And the magnitude of the weight is W. So now we have 3 vectors. We know the coordinate point, this coordinate point, so we know we can calculate the lambda vector, lambda vector, lambda vector. So there are 3 force vectors. So this will take us vectors. So there are 4 vectors. So then resultant should go to 0 means summation of all the 4 vectors should go to 0. So TAB vector plus TAC vector plus TAD vector plus W vector should go to 0. Is it fine? Right. So now you know this is in 3D space, so it will have x component, y component and z component. So this will have x, y, z, this will have x, y, z, because all the three are inclined to all the three axes. Okay, and this will have only, okay, y component, or it is in the y direction, vertically downward. So now we can sum all these components, that will go to 0. So x of this, x of this, x of this, or I vectors, you add all the I vectors, you add all the j vectors, add all the k vectors and equate to 0. So all x go to 0. Summation of fx I vector plus or minus, we do not know, summation of fy j vector, summation of plus or minus, summation of f z k vector to 0. Obviously, summation of fx has to go to 0, summation of fy has to go to 0, summation of fz is 0. Now, for 3-dimensional space or 3-dimensional problem, we have 3 equations. Obviously, we will be able to find 3 unknowns. So 3 equations, 3 unknowns.
Okay. Now let us solve this problem. The point A is in equilibrium by the application of force P, and 200 kg mass is, the weight is acting downward, and this is held in this position by means of 2 strings or cables, okay, and which are tied at B and C. The coordinate values are given. You take this as the reference point O. So with respect to this point, A coordinate is, the x1 is 1.2, y1 is 2 meter height, and it is in this line, in this plane. So there's no z distance, so z1 goes to 0. So the coordinate for A is 1.2, 2, 0. The coordinate of B, right? So if it is a wall, okay, so there's no x distance. So with respect to this point, O point, it is in the same plane. So x 0, y is 12 meter, and z is plus 8, because z is coming right this direction. So the coordinate for B is 0, 12, 8. C 0, 12, minus 10, because from this plane it is behind the plane. It is behind the plane. So it is negative z direction. It is in the negative z direction. So the coordinate for C is 0, 12, minus 10. Okay, it is in equilibrium. We have to find this tension, and this P. What is asked? What is the P that keeps the body in equilibrium? Okay, so 3 unknowns can be found out, because the equilibrium equations are summation of fx equal to 0, fy equal to 0, and fz equal to 0. So 3 unknowns can be found out. In this problem, P is one unknown, The tension in AB is another unknown. Tension in AC is another unknown.
So the coordinates for the given problem are: A point is 1.2 meter in x distance, y is 2 meter, and z is 0. B point is 0, 12 and 8. Similarly, for C, 12 minus 10. Okay. So in the given problem, there are 4 vectors, 2 ropes. Okay, say this is the wall. Okay, one rope is tied like this, another rope is tied like this, and assume this is point A, this is point A, and the weight is hanging down. The weight is 1.2 meter from the wall, and from the floor it is 2 meter, right, height. It is like this. So one rope, another rope, these two will have the tensions T, A, B vector, okay, and then we have T, A, C vector, okay. Then in the x direction, this weight is pulled by another string, okay. Directly the force is applied onto the point A to keep the body in equilibrium, okay. So that force, since the coordinate points are not there, so it is a vector P vector in x directions. That is the magnitude of the P into I vector, since it is in the positive x direction, okay. W vector is, W is the magnitude, and conventionally we use upward is positive, since it is acting downward it is negative J vector. So these two vectors known, and this weight is given, 250 kg is given, so 9.81 if you put, if you calculate, then we get the weight, right? P we have to find out. And then what is this vectors? These two vectors we have to find, since the coordinate points are given, right? And we will be able to find out the unit vector, the lambda vector, okay. So TAB is the magnitude and lambda AB is the unit vector in that direction. TAC is the magnitude, lambda AC vector is the unit vector, okay. It gives the direction, and this is the magnitude that gives the corresponding vector, okay. All these are forces, and then we can add all these three, TAB vector plus TAC vector plus P vector plus W vector equals to 0, right. Now if you substitute all this and equate to 0, finally it will lead to summation of fx equal to 0, summation of fy equal to 0, summation of fz equal to 0. Now let us find out this vector TAB vector. For that I need lambda AB vector. So what is lambda AB vector? Lambda AB vector is AB vector by AB, okay. So what is this AB vector? Distance I vector, distance x distance I vector, y distance j vector plus z distance k vector by the AB distance, okay. So now what is this D? under root dx square plus dy square plus dz square. Right? So now what is dx? Dx is x2 minus x1. So this is the particle which is in equilibrium. Okay, so always take that as x1, y1, z1. Now when I am discussing AB, we are discussing only AB. So this becomes x2, y2, z2. Okay, so 0 minus 1.2 equal to minus 1.2. Then dy y2 minus y1. So y2 12 minus 2, 12 minus 2 equal to 10. Then dz, z2 minus z1, 8 minus 0, 8. Okay, so then d equal to, substitute 1.2 square plus 10 square plus 8 square, we will get 12.862. 12.862. Okay, so now we can substitute all this inside. So lambda a b vector equal to minus 1.2 I vector plus 10 j vector plus 8 k vector divided by 12.862. Right? So now TAB vector equal to TAB. Okay, and then you can substitute all this. So finally you get 1.2 divided by 12.862 minus 0.0933 TAB I vector. Okay, plus 0.7775 TAB J vector, right, plus 8 by 12.862 0.622 TAB K vector. So we get one vector, we have obtained this, and now in a similar fashion we have to find out, okay, AC. This becomes x2, y2 is a 2, right? So dx lambda AC vector by AC is x2 minus x1, so minus 1.2 I vector, 12 minus 2, so plus 10 j vector, minus 10 minus 0, minus 10 k vector divided by under root 1.2 square plus 10 square minus plus 10 square. Right? So this value is 14.193. Right? So when you are substituting this TAC vector, okay, so 1.2 divided by 14.193 into TAC. So this comes minus 0.8455 TAC I vector plus 0.7046 TAC J vector minus 7046 TAC K vector. Okay, so we have obtained all the 4 vectors. Now we have to add all i's which corresponds to x. Summation of fx equal to 0. So all x I have to put, I have to take. So this is one x, this is another x. Okay, so minus 0933 TAP. We need not use I here. Okay, minus 0.08455 TAC. Already we have other 2 vectors, P vector equal to Pi vector, W vector equal to minus Wj vector. So plus P equals to 0. This is one expression. Summation of Fy equal to 0. Okay, you take j's. So 0.775 TA B. Okay, this is plus, so plus 0.7046 TAC and then minus W equals to 0. This is expression 2. Summation of Fz equal to 0. Take all Z, case. There are only 2 case, so 0.622 TAB minus 0.7046 TAC equal to 0. This is 3. Upon solving, P equal to 235 Newton, TAB equal to 1402 Newton, TAC equal to 1238 Newton. Quickly to summarize, the only important point is how to find the force vector for a particular force. Initial and end positions are known, so the coordinates are known. Then how to find the force vector, that is important. And then the resultant should go to 0. Okay, I hope you have understood it in a better way. Thank you.